Okay, let's do another example. Suppose we have a set of data x1, y1 through x6, y6 as follows. x1 is 0, 2, x2 is 1, 2, x3 is 2, 0, x4 is 2, 1, x5 is 3, 3, and x6 is 4, 4. With y1 and y2 being k1, which is 1, y3 and 4 being k2, which is 2, and y5 and y6 are k3, which is 3. Apply linear discriminant analysis by doing the following. A. Find estimates for the linear discriminant functions delta 1, delta 2, and delta 3. B. Find the line that decides between each pair of classes. C. Classify the new point 1, 3. Okay, so if we graph the data points, we get this. Okay. So, as you can see, we have 3 classes here, 2 in each class. The number of features, P, is 2. The number of classes, big K, is 3. The total number of data points, N, is 6. The number N1 of data points in class K1 is 2. The number N2 of data points in class K2 is 2. And the number N3 of data points in class K3 is 2. Okay, first we will find estimates for pi 1, pi 2, and pi 3. The prior probabilities that y equals to k1, y equals to k2, and y equals to k3 respectively. So pi 1, pi 2, and pi 3. We want estimates for those. Then we will find estimates for mu1, mu2, and mu3, the class-specific mean vectors. We can then calculate the estimate for the covariance matrix sigma. Okay, finally, using the estimates, pi 1 hat, pi 2 hat, pi 3 hat, mu 1 hat, mu 2 hat, mu 3 hat, and sigma hat. Using these estimates, we can find the estimates for the linear discriminant functions, delta 1, delta 2, and delta 3. Okay, we can find estimates for these. Okay, so pi 1 hat is given by n1 over n. So we have 2 over 6, which is 1/3. Okay, pi 2 hat is n2 over n, which is the same thing. 2 over 6, which is 1/3. Pi 3 hat is n3 over n, and that's 2 over 6, which is 1/3. Okay, now mu1 hat is given by 1 over n1 the sum of xi, where yi is 1. Okay, so that's 1 over 2. Now the x's that are of class 1 are the first two, so that's x1 and x2. So we get this. Mu2 hat is 1 over n2, sum of the x's where the class is 2. So that's going to be 1/2 x3 plus x4 and we get 2 1/2. Mu sub 3 hat is 1 over n3, the sum of the x's which are of class 3, and those were the last two data points, x5 and x6. Okay, so that's 7/2. 7/2. Okay, sigma hat is 1 over n minus k, the sum over k, the sum over I of this. Okay, plugging in n equals to 6 and k equals to 3, we get this. Okay, so that's 1 over 6 minus 3 times this, and that reduces to this matrix. Okay, so sigma hat inverse is this matrix. Delta 1 hat of x is given by this formula, with mu 1 hat and pi 1 hat here. Okay, so using sigma hat and mu 1 hat, we get this. If you multiply that out, get this. Multiply all this out, we get 13/2. And then pi 1 hat was 1/3. Okay, here, let's rewrite this in terms of the components of x. So that's -2 x1 plus 7 x2 and the remaining stuff. Okay, now delta 2 hat of x is given by this formula. The same thing as delta 1, except we have mu sub 2 hat and pi sub 2 hat. Okay, for this we get 7 and -2. Calculate this out. And pi 2 hat was 1/3. Okay, rewrite this in terms of the components of x. And we get this. Delta sub 3 hat of x is this. Same thing, except we have mu 3 and pi 3. Okay, for this we get 7/7. For this, we get 49 over 2. Pi 3 hat was 1/3. Okay, multiply this out. Okay. Now setting delta 1 hat equal to delta 2 hat, we get this. So we get 13/2 and log of 1/3. Those cancel out. Okay, bring this to x2 over. We get 9x2. Bring that to x1 over this side. We get 9x1. Cancel the 9s. We get x2 equals x1. Okay, so the line that decides between classes k1 and k2 is given by x2 equals x1. Okay, setting delta 1 equals delta 3, we get this. And the 13/2 and the log of 1/3, those cancel. Sorry, the log of 1/3 cancels out. And the 49/2 we can bring over here. So we get 18. And the 7x2, those cancel out. Bring the 2x1 over. We get 9x1. Okay, so divide out by the 9. We get x1 equals x1 equals to 2. So the line that decides between classes k1 and k3 is given by x1 equals to 2. Okay, now setting delta 2 equals delta 3, we get this. Okay, and now the log of 1/3 cancel out. Bring the 49/2 over here. We get 18. 7x1 cancels out. Bring the 2x2 over. Simplify. We get x2 equals 2. So the line that decides between classes k2 and k3 is given by x2 equals 2. Okay, so if we graph those lines, then we get this. Now the lines, they divide the plane into 3 regions. 1, 2, and 3. Okay, if delta 1 hat of x is bigger than delta 2 hat, that corresponds to the region above the line x2 equals x1. Okay, so that would be above this line here. Conversely, if delta 1 is less than delta 2, that corresponds to the region below the line x2 equals x1. Okay, now delta 1 hat of x greater than delta 3 hat of x, that corresponds to the region to the left of the line x1 equals 2. So that's this vertical line here. Okay. Conversely, delta 1 being less than delta 3, that corresponds to the region to the right of x1 equals to 2. Now delta 2 hat of x greater than delta 3 hat of x. Okay, that corresponds to the region below the line x2 equals to 2. That's this horizontal line here. Conversely, delta 2 less than delta 3 corresponds to the region above the line x2 equals to 2. Okay, if delta 1 is bigger than delta 2 and delta 3, then we classify x as of class K1. So if x is in region 1, then we classify x as of class K1. Conversely, if x is in region 2, then we classify x as of class K2. And if x is in region 3, we classify x as of class K3. The point 1, 3, that's here, is in region 1, so we classify it as of class K1.